Hello everyone, reporting today for Fun Robotics Network. I'm Abbas, and with me here is Team 17077, Adna Robotics from Adna, Washington. Adna Robotics has had an incredible season so far for Into the Deep. They recently competed at their Asimov semifinal, ending with a top 20 OPR, winning Lions first pick, 6th highest score in the world, just great all around. There is so much going on with this robot, and I can't wait to jump into it on Behind the Bot. Okay guys, so yeah, you've had an incredible season so far, and there's just classic carbon fiber robot, super fast, everything we expect from Adna. I guess my first question is, like, coming into the Deep season, what was your approach to the game when you first saw it?
Right, so we had in the last years, we were always pretty much running a two-stage system, so we didn't really have a lot of experience switching slides, so we kind of ruled that out at the start. And we were just like, we had a lot of experience before with an active intake, especially in our center stage, and so we have an active intake, which then transfers it to the slides, and we were able to reuse our tested slides from the last 2 years, so we were able to run a good system which already was tested, so we could start scoring and having a good second life pretty early on, and then after we were able to score well, we were focusing on the hang to earn as much points as possible.
Yeah, definitely. So, relying on your experience, I think, is something a lot of teams can look to for success. Now, starting with your active intake, can you walk us through the collection mechanism itself?
Right, so we're going into submersible, then we are able to tip down, and we were running 2 Axon servos on our intake because we already have 8 on the rest, and it's just not as heavy. We gear them up to about 600 RPM, and then we just have the active intake, which rotates them and then just goes in and initiates the transfer on that.
Mm-hmm. And as far as it came to making iterations from the first design of this intake collection system to what you have now, what do you think were some of the biggest improvements you made?
So definitely having a metal plate in the front, because some of the especially the side panel piece of the submersible, they can be really sharp. So if we have put them out at the wrong point, or if you just grab another robot accidentally with it, it was just breaking our panel there. So we switched that to metal. That made our thing a lot more durable, our intake. And then just gearing it up, we had it on a 1-to-1 ratio with an Axon servo, which wasn't that fast. So we geared them up to a lot higher speeds, which then made us capable of intaking a lot faster.
Mm-hmm. And as far as sensors go for your intake, are there any sensors you use? If so, how do you use them?
Yeah, so we have a lot of driver optimization in there. Just we can detect if we have 2 blocks in there, then we spit one automatically out. If we have the right color in there, it automatically starts to transfer, or wrong color, it can spit it out. And it can also have a sensor that detects if the block is at the right position for the transfer, so it makes a transfer, which is pretty quick.
And so you mentioned, if you have 2 samples, you'll spit one out. Does that mean you have 2 different color sensors, or is it just one sensor you're using to detect 2 different samples? How does that work?
Right, so we actually have 3 in there. One is for seeing if it's in right distance for having a transfer in there, so we are always consistent. Then the second one we're just using for detection if we have one in there, in color sensor. And the third one we're actually just using the proximity sensor in the front to just see if there's another one in the front, which also helps us in autonomous because we can see if we even have a block in there, so it can be even faster there.
Very cool. And last thing I want to ask about the intake. So I see you have a single set of Go Build a slides, Viper slides, belted for that intake. Did you ever consider using 2, or was it just one was rigid enough? And would you recommend teams do the same?
So we don't really have a lot of issues. We can slightly turn it, but that's not really an issue because we can fully go to the ground, and just took up less space for us, and we can go into the edge of the submersible without really having our slide blocking us in there. So it was really just easy to implement, and it's just really small, and we can actuate them at a really high speed just with having one motor on them.
That makes a ton of sense. Now, going on to your lift, I know you mentioned that you're using the same belt system, belted slides as you have been for the past 2 years. So it's really awesome seeing how consistent that is. I think obviously the magic here is in the actuation with just the whole gearbox assembly, PTO, everything. So why don't you just walk us through that, and then I'm sure I'll have a ton more questions.
Right, so we just have two sets of belt slide sides, which are just routed continuously in there. and we have three motors on there, three bear motors, which we then gear up to here. And we're capable of just using it as a PTO to just transfer all the energy into our hang without having to actuate our lift, which would block us from hanging. And then we have a really high acceleration, high top speed because of having three motors, which especially makes our autonomous the first couple of cycles.
And can we see that, like the PTO from the bottom, if you don't mind?
Here we have like the gearbox, like the gear train, like on one side that's all for just having the slides on it, and then we just like kind of have the ability to switch it on and shift it onto gear to then actuate the entire hang system with it without moving the like during where we do that.
And so for I've heard you also have a gear shifter in there. So to actuate that gear shifting in the PTO, what is it? Just like a single servo, and how does that mechanism look?
Right. So that's pretty much down here. We just have a single. We'll build a speed servo in there, which then just shifts it on there. We don't need a ton of torque. Just shift in there and then just swaps it on there. We just then start rotating it and then just shift in the right position, which is just like actuate it right here by this one servo on there to be able to, because we only ever once in a match before.
And as far as controls go, with the PTO, are you guys having your encoders and your sensors on the like final spool or like pulley axles, or do you use the motor encoders for those typically?
We're using the motor encoders because we have the limit switch for a lift, so we can re-zero its position. So we don't really have an issue with that, and then we just reset all our encoders when we start our hang, and then this runs pretty without any issues because we're engaged mechanically, so we can't really have any drift on there for having the hang. And it has a pretty high gear ratio, so if we're like slightly off, it doesn't really matter.
Awesome. And before we get into your lift, because I know it's just such a cool mechanism, I want to ask about the carbon fiber. You guys have been using carbon fiber very consistently for the last at least 2-3 seasons. Do you know how much your robot weighs right now? And if you were to replace the carbon fiber with all the aluminum, how much heavier it would be?
So we're actually pretty heavy, especially because like our hang system and our gear shifter right now, we have like it was like 33 pounds at the moment roundabout, and we have like 4.5 pounds of carbon fiber on it because we have our entire hang system out of carbon. We don't really exactly know how heavy it would be, but it will probably be we'll probably put it over 35 pounds.
Got it. Okay, so now let's go through the whole hang. Just walk me through the process, and then I'll get into specific questions.
Right. So at the start of it, we can just actuate the gear shifter on there, and then we can pretty much just I'll do that manually. Just deploy the arm that should be like in the 18-inch step to start. Then we hook onto here. Then we like lift it upwards, engage in our passive hooks, and then we just are able to retract the system. So.
Okay, yeah, and so that's just for the level 2, correct?
We're going directly to level 3 because we're engaging to the first bar right here, only leaning against the bottom bar. Then we're going up to the highest bar with those hooks, and then we can retract it, and then we pretty much have a one-stage system which is capable to reach level 3.
Okay, and so was this the first system you guys tried for your hang, or was it a lot of trial and error and trying other things before settling on this design?
Not really. We started with the tape measure hang, especially for level 2, like at the start of the season, but it was just like hard to align sometimes, and we had the issue. It wasn't that rigid, and it was just after the robot got pretty heavy, we just had sometimes the issues that we like. It wasn't as fast, and the tape measures made us a lot of problems, especially because we had to go around the second bar at that point. So it was really convenient that we could just lean against the bottom of the submersible to be able to just go up without having to swing. Because of the weight of a robot, we were swinging like a really long time. If we don't stop ourselves,
that makes a lot of sense. So now, as far as like automation is concerned in the hang, how long does it take you to hang, and have you automated any of the process?
So we have automated the deployment. It just goes to a perfect position, and then for the rest of the 2, I just press 2 buttons to just lift it up and down, which is just there. And it depends how much battery we have left. It takes about 11 seconds when we have full battery, and like 12 to 13 seconds if we have an empty battery to just round it out. But we can also improve like the alignment time, which is like thing that costs the most time at the moment for us.
Very cool. And so now looking forward to the Washington Championship. It's coming up in about a week. About a week. And, Washington is always very competitive. As far as strategy is concerned, how has your strategy changed approaching the Washington State Championship?
So I would say that our strategy hasn't changed all too much. We're really just trying to rely on our speed and our driver abilities. So we've stayed consistent throughout the season. We've really built upon what we have had previously. We've kind of stayed consistent, possibly just looking forward to making our robot all that much better.
Okay, cool. And so is it still focused is going to be on the sample cycles in the basket, or are you guys thinking about trying specimen at all, or not really?
We're still focusing mainly on samples.
Okay, and as far as autonomous is concerned, I mean, the 4-sample autonomous, bare minimum, of course. Looking towards states, do you expect to be getting 5 or 6 samples in autonomous, and if so, how?
So we were already running 6 SMF. It wasn't 100% consistent yet. We were getting 5 most of the time, but we are working on getting 6 really consistent, and we're trying to even get 7 samples in autonomous. Sometimes if we intake the right blocker or something like that.
Mm-hmm. And so when it comes to picking samples in the submersible zone, what is your strategy there? Is it just kind of going to the same area every single time, or do you want to do you have any sort of detection to look at the samples and pick them? How does that work?
No, we don't really currently have any detection, but we have our color sensor, so we can just put it in there, detect. We can intake one if there's someone there, and then we have a timeout of a short time if we don't reach any, but we don't get one most of the time. But if we should get the wrong color at some point, we're just going to spit it out, go 5 inches to the side, and then just try again, which is pretty consistent. So we get 6 most of the time, even if we have to go at wrong trying. If we get the right one every single time, we're about 7 at the moment.
Okay, very cool. All right, Adna, thank you guys so much. I mean, you guys always just have the craziest robots, and I really can't wait to see how you're going to do at Washington Championship this year. I think this season is one of your most consistent, and that hang is just so cool. I'm really glad we were able to show our audience exactly how it works and what's going on and things like that. So, reporting for Fun Robotics Network, I'm Abbas, and this is Team 17077, Adna Robotics. Thank you.